In the world of modern military aviation, one thing remains constant: technology never stands still. Every decade, new platforms emerge that change the way countries view security and air power. And right now, the attention of global defense analysts is focused on one aircraft that is being called one of the most daring technological leaps in the history of Asian aviation, the J-50, a sixth-generation fighter jet currently being developed by China. Section 1. From conventional jets to system platforms, the great evolution of Chinese aviation. To understand the J-50, we need to look at the big picture of Chinese aviation technology development over the past 3 decades. In the 1990s, the country's aviation industry was still heavily dependent on Soviet designs and imported technology. However, what is interesting is not its weaknesses, but its strategy for change. Phases of technological development. Imitation and licensing. Licensed production of the Su-27-based J-11 opened the door to understanding modern aircraft design. Reverse engineering and adaptation. Platforms such as the J-15 and J-16 emerged when the industry began to develop independent modifications and improvements. Independent design. The emergence of the J-20 signaled that China had entered a new era: stealth design with avionics and materials developed domestically. New generation innovation. The J-50 is the next step. No longer playing catch-up, but starting to create new standards based on local research. This transformation shows one thing: China's technological capacity is increasing faster than many Western institutions projected in the early 2000s. Section 2. Sixth-generation aerodynamic design. Focus on efficiency and stealth. One of the most unique aspects of the J-50 is its different approach to aerodynamic design. The Lambda Wing concept. Instead of following the delta or trapezoidal shape of many modern fighter jets, the J-50 adopts a geometry similar to the letter lambda. Advantages. Supersonic drag can be significantly reduced. Stability is improved at extreme angles of attack, an area that is usually challenging for tailless jets. Airflow management becomes more efficient, supporting maneuvers at high speeds. 360-degree rotating wing system. This technology is rarely used in operational jets due to its structural complexity. However, if properly implemented, the jet can dynamically adjust lift direction. Close-range maneuvering performance improves dramatically. Low-speed stability for carrier operations also improves. Such technology is not merely an aerodynamic gimmick, but part of a single integrated system that forms the core of the J-50's design. Section 3. Advanced materials and competitive radar signature. The stealth approach in the 5th generation typically focuses on controlled geometric surfaces, wave-absorbing materials, weapon placement in internal weapon bays. The J-50 takes this concept further through a combination of composite materials and a tailless structure. The elimination of vertical surfaces such as vertical stabilizers has the potential to reduce the radar cross-section from the sides and front, lower the radar signature during high-G maneuvers, slow down detection by high-frequency radar. In addition, China is developing wave-absorbing materials that are more integrated with the aircraft structure. This approach is similar to the research direction of Western countries, but is being pursued through a different path. Section 4. Engines and propulsion. It's not about power, but efficiency. This is where many people misunderstand. The next generation is not only pursuing faster or stronger, but also greater efficiency. The new engine developed for the J-50 is said to prioritize not only thrust, but also supercruise without afterburner, low heat ratio to reduce infrared signature, more efficient fuel consumption for greater range. Even if the thrust figures aren't as high as Western engines, the design focus is on thrust-to-weight ratio, not raw numbers. Section 5. Artificial intelligence, the biggest transformation. If one had to choose the technology that most distinguishes the J-50 from previous generations, the answer would be combat mission AI. The AI system on the J-50 is designed to identify threats faster than humans, Manage dozens of targets simultaneously. Optimize routes to avoid enemy radar. Arrange weapons based on priority and distance. Coordinate with combat drones in swarm scenarios. The concept of pilot as commander, AI as tactical operator is becoming the new standard in aviation research. This is not just a matter of automation, but reflects the direction of the future. Manned and unmanned platforms working as a single digital ecosystem. Section 6. Network Architecture, Data-Based Air Warfare. Older generation jets prioritize flight performance and internal sensors. The 6th generation prioritizes network groups. The J-50 was created to function as a central node in the combat network, a companion drone manager, a real-time data collector and processor, a link between satellites, ground radars, and other air platforms. The result is a collaborative combat system where data is the primary weapon. Section 7. Swarm Systems and Loyal Wingmen. One of the most notable concepts in global defense research is the integration of manned jets, unmanned jets, data collection drones, light attack platforms. The J-50 is projected to be capable of controlling multiple unmanned aerial vehicles in a single mission. This concept will open up possibilities such as sending drones on high-risk missions, increasing the number of targets that opponents must deal with, optimizing the use of long-range weapons, reducing the risk of pilot loss. This step is in line with global trends, with the US, Europe, and Australia also developing the loyal wingman concept. Section 8. Future Simulation, How 6th Generation Jets Change Strategy. Simulations conducted by various defense agencies around the world show that 6th generation systems have a major impact on air superiority, deterrence, mission efficiency, human risk management, with capabilities such as long-range detection, AI data management, drone swarm control, unmanned operations when necessary. 6th generation jets such as the J-50 have the potential to change the way countries plan their air strategies. Section 9. Global Impact, Technological Competition, and New Geopolitical Directions. The emergence of the J-50 concept has several global consequences. A. Developed countries. The U.S. is accelerating its next-generation air dominance (NGAD) program. Europe is strengthening Project Tempest and FCAS. Japan and South Korea are beginning to develop new AI-based concepts. B. Developing countries. Many countries are evaluating. Should they continue purchasing 5th generation jets? Or jump directly to 6th generation AI-based concepts and loyal wingmen? C. Future defense dynamics. These platforms are not just military tools, but also drivers of AI innovation, advanced materials, optical sensors and radar, military network technology. In other words, 6th generation jets are not just an aerial competition, but a global technology competition.